Quantum computing is not just an emerging field, it's a technological leap that could redefine the future of science, industry, and global security. Unlike classical computers, which process data using bits, quantum computers use quantum bits or qubits. These qubits exploit the principles of quantum mechanics, allowing them to perform complex calculations at speeds and with efficiencies far beyond the capabilities of traditional computers. Quantum computing could revolutionize sectors like cryptography, artificial intelligence, materials science, and drug discovery, solving problems that would otherwise take centuries. As the world races to harness the potential of quantum computing, China has emerged as one of the most prominent players, aggressively investing in research and development. The country's focus on quantum technology is not just academic, it is a strategic national endeavor. China has made significant strides in quantum computing, with breakthroughs that are setting new benchmarks for the global industry. With government-backed funding, ambitious goals, and a rapidly expanding talent pool, China's role in the quantum race has become a focal point in discussions about global technological supremacy. The global quantum race is intense, with major powers like the United States, the European Union, and China vying for leadership. Each country is pouring billions of dollars into quantum research, aiming to be the first to achieve what is known as quantum supremacy, the point at which a quantum computer can outperform a classical computer in solving specific problems. China has made remarkable strides in this race, positioning itself as a serious competitor. While the United States and other countries have historically led in quantum computing research, China's aggressive government support and increasing focus on developing cutting-edge quantum technologies have allowed it to close the gap rapidly. For example, China's quantum research budget in 2020 was estimated to exceed $10 billion, a clear indicator of its commitment to leading in this space. As of 2021, China has made significant progress in developing quantum processors, and its National Quantum Laboratory has become a hub of innovation. With this continued momentum, China's role in the quantum race is expected to grow, potentially giving it a competitive edge in shaping the future of this revolutionary technology. Quantum supremacy is a landmark achievement in the world of quantum computing. It refers to the point at which a quantum computer can solve problems that would take even the most powerful classical supercomputers an impractical amount of time. Google claimed to have achieved quantum supremacy in 2019 with its Sycamore processor, which completed a specific task in 200 seconds that would take the world's most advanced supercomputers thousands of years. While this breakthrough was significant, China has now set its sights on not just achieving quantum supremacy, but on surpassing Google's achievement. In 2021, China announced that it had developed the Zhuangzi 2 processor, capable of performing quantum calculations in a fraction of the time it would take traditional computers. This move marks a critical step in China's ambition to not only compete with but potentially lead the global quantum race. By surpassing the benchmarks set by previous quantum supremacy claims, China is laying the groundwork for becoming the global leader in quantum computing. China's quantum computing breakthroughs include several notable advancements, with the Zhuangzi processors standing out as some of the country's most impressive achievements. The Zhuangzi 2, for example, is a quantum processor based on superconducting qubits, and it represents a major milestone in China's quantum research. Unlike classical processors, which use electrical circuits to process information, superconducting qubits rely on quantum properties like superposition and entanglement to handle vast amounts of data in parallel. The Zhuangzi 2 processor demonstrated an ability to perform quantum calculations at an astonishing rate, outperforming previous attempts at quantum supremacy. In addition to this, China has also been developing the Zhuangzi 3, an even more advanced quantum processor that is expected to surpass the capabilities of the Zhuangzi 2. These breakthroughs are significant because they show China's capacity to push the limits of what is possible in quantum computing and are setting the stage for future advancements that could have widespread applications across industries. One of the most exciting areas of China's quantum research is its focus on superconducting qubits and photonic quantum computing. Superconducting qubits are made from superconducting circuits that can carry electrical currents with zero resistance. These qubits are often used in quantum processors like Zhuangzi because they are highly stable and capable of performing quantum computations with lower error rates. Photonic quantum computing, on the other hand, uses particles of light, photons, to perform quantum computations. Photons are less susceptible to environmental interference, making them an attractive option for developing scalable quantum computers. China has made significant progress in both areas, positioning itself as a leader in the development of scalable and error-resistant quantum systems. By combining these two technologies, China is pushing the boundaries of quantum computing, with the aim of creating systems that can eventually outperform traditional supercomputers in a wide range of applications. The Chinese government has been a major driver behind the country's quantum computing advancements. Through national programs, strategic investments, and the establishment of quantum research institutes, China has ensured that quantum technology remains a key focus. In 2016, China established the National Quantum Laboratory, which has become a focal point for research and development in quantum technologies. The government has also provided significant funding for quantum projects, with the expectation that quantum breakthroughs will not only advance scientific knowledge but also provide significant economic and strategic benefits. China's investment in quantum computing has been bolstered by its broader technological ambitions, such as the desire to establish dominance in areas like AI, 5G, and semiconductors. Quantum computing is seen as a critical technology that could provide China with an advantage in these areas, enabling breakthroughs in areas like secure communications and artificial intelligence. The government's active involvement and support are helping China to accelerate its progress in quantum computing, ensuring that it remains competitive on the world stage. One of China's most ambitious goals in quantum computing is the development of quantum cryptography. Quantum cryptography relies on the principles of quantum mechanics to create secure communication channels that are impossible to hack without detection. China is leading the world in this technology, having already launched its first quantum satellite, MISHUS, in 2016. The MISHUS satellite is designed to test quantum key distribution, QKD, which enables secure communication between distant locations. This technology could render traditional encryption methods obsolete, providing an unprecedented level of security for digital communications. China has also announced plans to create a global quantum internet, which would connect quantum computers and allow for the transfer of secure data across the world. This ambitious initiative could fundamentally transform global communications, creating a new era of secure and tamper-proof data transfer. While China's advancements in quantum computing are impressive, they also raise several ethical and security concerns. One of the primary issues is the potential impact of quantum computing on current encryption systems. Quantum computers are capable of solving complex mathematical problems much faster than traditional computers, meaning that they could easily break many of the encryption protocols currently used to secure everything from banking transactions to military communications. This has led to concerns about the security of sensitive data in a post-quantum world. Additionally, there are concerns about the military and surveillance applications of quantum technology. Quantum-enabled hacking, surveillance, and weaponry could drastically alter the balance of power in global security. As China leads the way in quantum computing, it will be crucial for the global community to address these concerns and develop new methods of encryption and security to safeguard against the potential risks posed by quantum technology. China's advancements in quantum computing are reshaping the global technological landscape. With groundbreaking achievements in quantum processors, quantum cryptography, and AI integration, China is setting itself up as a dominant force in the future of computing. Its aggressive investment in research, development, and talent acquisition ensures that the country will continue to lead in this critical area of technology. The implications of these breakthroughs are far-reaching, from revolutionizing industries like AI and cybersecurity to potentially disrupting the balance of power in global geopolitics. As quantum computing progresses, it will play a pivotal role in shaping the future of technology and the global economy. With China at the forefront of these advancements, the world is witnessing a technological race unlike any other, one that could have profound effects on the future of innovation and global security. The next few years will likely be crucial as nations, companies, and research institutions continue to race toward achieving quantum supremacy and unlocking the full potential of quantum computing.